All right, welcome back. So we're on to the last two examples here. So the third example, still finding perimeter and area for the composite shape. So again, I like doing the perimeter underneath. It's the easier one because it's usually just following around on the shape. Um, this is going to be an interesting one. So perimeter again is A plus B plus C plus dot dot dot. So perimeter, I'm going to start right here. So I go across. So 1 plus. I'm going to go all the way to the bottom. Plus 8. Come across. Now it's the same as the other end, so it's plus 1. Now, here's a tricky thing. I got to find that length right there. So this is like a bonus question. Does anyone know how to find that length? We technically haven't covered this in the course. I know you do it in grade 8. So what happens here is this shape here forms a special triangle, and it's a right triangle. All right. So we have to find or use Pythagorean theorem to solve this. So we are going to come back to this officially later on in the course. So if you don't remember that, that's fine. Probably won't put a question like this on the test, but our Pythagorean theorem is the hypotenuse squared equals side A squared plus B squared. So we're looking for hypotenuse. So A is 3.5 squared, and our base is going to be halfway, so it's going to be half of 8, which should be 4 squared. So our hypotenuse squared, what we do is we plug that into our calculator. So 3.5 squared plus the 4 squared, we get 28.25. Then we have to take the square root of both sides because we need to get the hypotenuse by itself. So the square root of the answer is 5.3 meters. All right, so that is going to be 5.3. Fortunately, this is an isosceles triangle, so that allows us to find both sides in one calculation. So 5.3 plus the final leg is 5.3. Again, if you don't remember Pythagorean theorem, okay, it is from the grade 8 course. We will be taking that up in more detail later on. Make sure a question like this doesn't make it on the test at this point until we make sure it's covered. So no worries there if you don't remember. So that comes out to a perimeter of 20.6 meters. All right, now area. Area equals, again, area 1 plus area 2 plus dot dot dot. How many areas do we have here? So most people, I'm hoping, see there's a skinny rectangle on the end. So that's my first area. And then the triangle is going to be area 2. So that means that area 1 is a rectangle, length times width, 1 times 8. So that gives us 8 meters squared. The second area is a triangle. Base times height divided by 2. You can look that up on your formula sheet that's provided. So what is the base? The base is the bottom of the triangle. So that's the 8. And the height is the value right there to the top vertex, which is 3.5. And then we divide that by 2 because it is a triangle. So we end up with 14 meters squared. So our area total then is A1 plus A2, 8 plus 14, so 22 meters squared for this shape. All right, so there's our area. Okay, last example. This one's a little bit trickier. All right, so for this one, what do we have going on? Well, let's start with perimeter. So perimeter equals side A plus B plus C and so on and so forth. So I'm going to start here where I normally start. I'm going to go along that whole length, and I see that it's 1.6 meters. Now I noticed the other measurements in centimeters, so I got to make a decision what I want to work in. It does not matter which one you choose. I'm going to work in centimeters. So this is 160 centimeters. So that first side over here is 160. Oops, I don't have to put the centimeters in here. Just 160 plus. Now we got to figure out what is this shape. All right, and I'm hoping most people say, oh, that is half a circle. Now, looking it up on your formula sheet, we don't have perimeter under circle, we have what we call circumference. And your formula will be circumference equals either 2 pi r or pi times the diameter. So it depends what information we have. So for this particular circle, we have our diameter. It's 90 centimeters. Now we only want half the circumference. So for this first one here, and let's call it C1, it's going to be pi times diameter divided by 2 because I only want half a circle. All right. So pi is about 3.14 for this course. The diameter is 90. We're going to divide that by 2. So that will allow me to find that distance there. So 3.14 times 90. Divide that by 2. So it's 141.3 centimeters approximately. All right. So now I know that length there. I can add that onto my perimeter formula. All right, traveling down here, it's going to be 160 centimeters. Now here's a trick. We're going around the outside of the shape. So what do we know this one? And the answer is, if it has the same diameter, it has to have the same circumference, or in this case, half circumference. So we can just add on that 141.3 again, okay? Doesn't matter whether you're traveling on a sort of inside of the circle or the outside, it's the same distance. So that allows us to find our perimeter. And I get that to come out to 602.6 centimeters. So there is our perimeter. Now we have to find area. So we have to work down here. So area, our total area is 1 area plus 2 area plus dot, dot, dot. Okay, so the first shape I see is the outside rectangle. So that's going to be my area 1. Now, I need to add on half a circle. So that's area 2. But this caves inward, so I'm going to have to subtract area 3. What do we know about area 2 and area 3? If they have the same diameter, so therefore area 2 has to equal area 3. What does that mean then? If those two areas are equal, but this one is an addition and this one is a subtraction, if they're equal, well, they cancel out. All right? So therefore, the two semicircles will cancel out. So that means that the area of this shape then, the total area, is simply area 1. Area 1 is length times width, 160 times 90. So if I calculate that, 160 times the 90, we get 14,400 centimeters squared. All right. If you would have went ahead and calculated them out, and you would have added area 2 and subtracted area 3, you would have got the same answer. All right, same amount of marks. But this is where I want you to use that ability to move shapes around and figure out, what is the area as a whole. So realizing that the positive half circle would cancel out the negative, or the half circle that was cut out is a plus. It saves you a lot of work. So anyway, if you have questions with any of the 4 examples, please, this is the time to ask your teacher for help to go through before you try any of the homework. And good luck, and we'll see you in the next video.